Introduction of crystalline solid space lattice and unit cell. We have to discuss about this topic today. At first, we know that matter has three phases. Matter has three phases like this. Solid phase, liquid phase, and gas. Now, we have to study about the solid phase here. In solid phase, there is a regular arrangement of molecule or ions. Very ordered arrangement of molecule or ions in solid phase. In liquid phase, there is a regular arrangement of molecule or ions in solid phase, like this. Compact arrangement of molecule or ions. There is very less intermolecular distance in the solid phase of the molecule. Very less intermolecular distance and high intermolecular force. While in liquid phase, the molecules are in less order in liquid phase. While in gas phase, the molecules are at randomness condition. Molecules are in randomness order. There is no any order in gas phase. So here we have to study about the solid phase. Solid are two types: amorphous solid and crystalline solid. Amorphous solid like the rubber. There is irregular pattern of the molecule or ion. That is amorphous solid. Covalent, generally in gaseous state or liquid state. Generally covalent, amorphous solid. Crystalline solid. In crystalline solid, molecules are in regular pattern and located in fixed position. These cannot be cut by the knife. While the amorphous solid can be cut by the knife, like rubber, semi-solid thing also. Now we have to study about the crystalline solid. In crystalline solid, like NaCl, magnesium chloride, calcium chloride, there is a building block element. There is a building block element of the crystalline solid. Like similarly, suppose that this building is composed of brick. Brick is the building block element of this building. Brick. एक ईंट जो है building block element होगी किसका? इस बिल्डिंग को बनाने, इस मकान को. Brick is the building block element of this building. So similarly, the whole crystal is the smallest unit that is called building block element of that crystal. That is called unit cell. Like this. Suppose that we have a crystal. This one is, this crystal has 8 cube. 1, 2, 3, 4, 5, 6, 7, 8. 8 cube in this crystal, and one is the building block element of this crystal, like this. Building block element, this is called unit cell. It was first discovered by Auguste Brevis in 1850. So Brevis lattice also called Brevis lattice. If it is difficulty, there is difficulty in sketching or drawing this diagram, then you can also sketch like this, two-dimensionally. 1, 2, 3, 4. This is two-dimensional structure of unit cell, right? Unit cell और Brevis lattice. इसी से पूरा क्रिस्टल बना. And we have different type of unit cell present in crystal. Due to type of unit cell, we have different type of crystals also. Like cubic, monoclinic, triclinic, hexagonal. There are so many type of unit cell in the crystal. जिस टाइप का यूनिट सेल होगा उसी टाइप का क्रिस्टल बनेगा, राइट? एट फर्स्ट टाइप ऑफ crystalline solid, type of crystalline solid. Crystalline solid are of 4 types. First, ionic solid. Second one is ionic solid. In ionic solid, ions form the ionic solid. Ionic solid is composed of ions like NaCl, MgCl2, calcium fluoride. All these are ionic solid. Ionic solid is composed of ions. Ionic solid has fixed shape and size. Ionic solid, aqueous solution of ionic solid is good conductor of electricity. Ionic solid is dissolved in soluble in ionic solid is soluble in polar solvent like H2O. Second one is molecular solid. Second one is molecular solid like HCl, H2O in ice form, that is molecular solid. H2O in ice form, that is crystalline solid but molecular solid. HCl in solid form, that is ionic solid, molecular solid. Third one is covalent or network like solid. Network like solid. Covalent or network like solid. What are the covalent or network solid? Network like solid. Have you heard any time covalent solid or network like solid? Covalent solids like graphite and diamonds. In graphite and diamonds, carbon having covalent bond. That is the allotrope of carbon. In graphite and diamonds also fullerenes, Buckminster fullerenes. Buckminster Fuller discovered the fullerene is the third allotrope of carbon. You can also sketch like this diamond. In diamond, the carbon is in tetrahedral structure like this and form network-like structure. There is network-like structure, so easily cannot be cut by the knife because of there is network-like structure like this. While in case of graphite, there is a sheet-like structure like this. A sheet-like structure like this. So easily cut by the knife. Each sheet can be removed by the knife. While in case of diamond, there is a complicated network-like structure and that cannot be cut by the knife because of it is the hard. This is type of covalent or network-like crystal. And fourth one is metallic crystal. Metallic crystal, suppose that Fe and any metal, aluminium, zinc, all these are metallic crystals. Sodium, in which metal is surrounded by electron cloud, and that is metallic crystal. Metal is surrounded by electron cloud. These are the type of crystalline solid. How many type of crystalline solid are there? Ionic solid, molecular solid, covalent solid, covalent or network-like solid, and metallic solid. Right? And there is also isotropy and anisotropy executed by the crystalline solid. Isotropy and anisotropy shown by the solid substance. What is the isotropy? If the electric conductivity in all direction, having same in all direction, electric conductivity flow in all direction. All direction में एक जगह को ये डायरेक्शन, किसी सॉलिड में सभी डायरेक्शन में इलेक्ट्रिक कंडक्टिविटी सेम फ्लो हो रही है, दैट इज कॉल्ड आइसोट्रोपी. Like in amorphous solid, if the electric conductivity does not flow or flow in different direction as a different, that is called anisotropy. Like this, this is different molecule. Suppose that this is anisotropy and this is isotropy. Same molecule है, magnetic anisotropy. Isotropy, you can say that isotropy. This one is anisotropy of the molecule. At first, we should know the habit of crystal. What is the habit of crystal? Habit of crystal, the external feature of crystal is called habit of crystal. The external feature of crystal is called habit of crystal. Like this. Habit of crystal. These are the phase. These are the phase. How many total phases are here? 6 phases are there. These are the phase. This one is upper phase, lower phase, and side phase. Total how many phases are there? 6 phases are there. The angle between two phases is called interfacial angle. The angle between two phases are called interfacial angle. It is important that the interfacial angle of any crystal are same. It is called law of constancy of interfacial angle. It is important character of any crystalline solid. Law of constancy of interfacial angle. Suppose that this is alpha, this angle is beta, this angle is gamma, right? How many total angle are there? 3 angle are alpha, beta and gamma. इस फेस और इस फेस के बीच में अल्फा, इस फेस और इस फेस के बीच में बीटा, और इस फेस और इस फेस के बीच में गामा. And these are A's, A, B, C. These are A's, A, B, C. Right? A, B, C and are A's. On the basis of these A's and interfacial angle, we have 7 type of crystal are possible. We have 7 type of crystal are possible. How? Suppose that A equal to B equal to C and alpha equal to beta equal to gamma equal to 90. A equal to B equal to C. क्या बनेगा? क्या बनेगा? क्यूब बनेगा. अगर ये फेस, ये और ऊंचाई, लंबाई, चौड़ाई सब बराबर हो, क्या बनेगा? क्यूब बनेगा. ठीक. क्या बनेगा? Telling about the 7 type of crystal system possible on the basis of unit cell. If alpha equal to beta equal to gamma equal to 90 degree, then A equal to B equal to C, there will be formation of QB. If alpha equal to beta equal to gamma equal to 90, alpha, beta, gamma, but A equal to B equal to not C, A equal to B not C, alpha equal to beta equal to gamma equal to 90. That will be found the tetragonal. All these are cuboid but tetragonal. That is called tetragonal. If the crystal is composed of that type of unit cell, and that crystal is called tetragonal. Right? Third one is that if A equal to B, A, B, C, alpha, beta or gamma. Alpha equal to beta equal to gamma equal to 90, but A equal to not B equal to not C. A equal to not B equal to not C सभी बराबर नहीं है. जैसे आपने CPU देखा ना, CPU कंप्यूटर का आगे का अलग, पीछे को अलग, ऊंचाई अलग. तो जस्ट लाइक CPU, A equal to not B equal to not C. Ortho rhombic. Third one type is orthorhombic. And fourth one hexagonal. 5-1 monoclinic. 6-1 triclinic. And 7-1 rhombohedron. In this way, we have 7 type of crystal system possible. All these unit cells are subdivided or divided on the basis of edge, distance of edge A, B, C, and angle between faces, interfacial angle. Right? Hexagonal. In hexagonal, there is angle of 120 also. Right? This is called 7 type of crystal system possible. Now, symmetry of crystal. Symmetry of crystal. In crystal there are three type of symmetry: plane of symmetry, second one is center of symmetry, third one is axis of symmetry. Symmetry in crystal: plane of symmetry, center of symmetry, and axis of symmetry. Any crystal, at first we have to discuss about plane of symmetry. Any imaginary plane which divide any crystal into two equal halves. Any imaginary plane drawn through the crystal, which divide any imaginary plane which divide any crystal into two equal halves. ऐसी प्लेन है जो बराबर दो हाफ में क्या कर रही है, डिवाइड कर रही है क्रिस्टल को. दैट इज कॉल्ड प्लेन ऑफ सिमेट्री. राइट, दिस इज कॉल्ड प्लेन ऑफ सिमेट्री. सेकंड वन इज सेंटर ऑफ सिमेट्री. Center of, what is the center of symmetry? Suppose that any crystal the point at the any crystal from which each face lies at the same distance. The point at the center of any crystal from which each face lie at the same distance. Each face lie at the same distance. Means if we move to this face and this distance will be same, and if we move to this face and this will be also same equal distance, and this distance also be equal. Right? This is called center of symmetry. That is called plane of symmetry. This is called center of symmetry. Now third one is axis of symmetry. Axis of symmetry is that a line drawn through the crystal, if we rotate that crystal at 360 degree, we got more than two similar positions. Right? Suppose that मैं इस क्रिस्टल को ऐसे घुमाऊं 180 पर, तो हमको एक सेम पोजीशन मिल जाएगी. फिर घुमाऊं तो फिर एक पोजीशन सेम मिल जाएगी. अगर ये लाइन यहाँ पर खींची होती तो 180 में घुमाने में सिमिलर पोजीशन नहीं मिलेगी. यहाँ इस साइड छोटा आ जाएगा, इस साइड बड़ा चले जाएगा. So that is not axis of symmetry. It should be similar, more than two similar positions. That is called axis of symmetry. Plane of symmetry, center of symmetry, and axis of symmetry. And type of crystal also I have discussed: covalent crystal, ionic crystal, and energy released when one mole of ionic solid is composed from its componental ions. The enthalpy change is called lattice energy. Important thing is that lattice energy is, what is the lattice energy? When one mole of ionic solid is formed from, when one mole of ionic solid is formed from its componental ions. Suppose that NaCl बन रहा है, राइट, NaCl बन रहा है और NaCl इट्स कंपोनेंटल आयन से बनेगा, Na पॉजिटिव और Cl नेगेटिव से. तो दैट विल कॉल lattice energy. And the concept of lattice energy by Born-Haber cycle. The concept of lattice energy by Born-Haber cycle. Suppose that Na solid is converted into any gas phase, heat of sublimation. Whenever solid is converted into gas phase, that is called heat of sublimation. Now, one electron removed from that Na, that is called ionization potential energy. Amount of energy required to remove the electron from any atom at outermost shell at its gaseous state or isolated state, that is called ionization potential or ionization enthalpy, right? And now Na become Na positive, Cl2 in gaseous phase, and now Cl2 molecule break down into two chlorine free radical like this. Then the amount of energy required to break the Cl2 molecule, that is called bond dissociation energy, D, denoted by D. And now Cl free radical form in gaseous phase. One electron is added in this Cl free radical, chlorine free radical, and Cl will be negatively charged ion. And energy released in this condition is called electron affinity. Now, these ions are formed. And these ions are formed, combined together to form NaCl molecule, crystalline solid. That is called energy released or required. Obviously, here energy released whenever the ionic solid is 1 mole of ionic solid is formed from its componental ions. The energy released, that is called lattice energy. That is called lattice energy, always in negative because of energy released here. When in molecular condition, that is called heat of formation. One mole of substance formed from its molecular condition, that is called heat of formation. Heat of formation, and this will be same. Delta H F, and this way on the basis of Hess law. This is called Born-Haber cycle. Born-Haber cycle is based on Hess law. What is the Hess law? Hess law ये कहता है कि कोई भी रिएक्शन वन वे में हो या मोर देन वन वे में हो, एक स्टेप में हो या मोर देन वन स्टेप हो, the energy change will be same. Means delta HF heat of formation equal to S plus ionization potential plus D plus electron affinity plus U. Heat of formation will be same in this way, either in this way or this way. Here the reaction is completed in more than one step. Here the reaction is completed in one step. Here more than one step. Sublimation energy, ionization potential, bond dissociation energy, this, and electron affinity and lattice energy. Then you can calculate the lattice energy from the help of Born-Haber cycle and heat of sublimation, ionization potential also, right?